We're here at Athens.
Hello.
Hello, and I'm with Frank, who's giving you a talk about RxJava reactive programming.
Yes, I am.
So let's talk about non-blocking code.
Okay.
So let's imagine that I am a server. I'm making a database request.
Yeah.
So what is a blocking request?
So usually when you do a request in blocking code, you would just send a request to the server, and then you wait and you wait until you get your reply. And all that time, that thread is doing nothing. It's just waiting for something to happen. And threads are actually quite expensive things to have lying around. It is true that threads can be scheduled. You don't need a physical CPU to run each thread. But still, you can maybe run a few hundred, few thousand threads in a system, and that's about it. While if you can make sure that you don't need the thread to wait around, you can do a lot more connections.
Free up resources.
Yeah, exactly.
So is there a difference between non-blocking code and, say, maybe just spawning off a new thread for each request?
Well, I mean, if you spawn off a new thread, it's still blocking.
Yeah.
You're still blocking a thread. You're blocking a different thread, perhaps. But in terms of resource, you're not helping anybody.
Yeah.
So that's more for if you want to run it asynchronously, that's one thing. But if you really want to have it non-blocking, then you need to have a method to do that.
Okay, so let's talk about a non-blocking method. So what's the process?
So generally, if you have a non-blocking request, you just send a message somewhere, and then you have some way, it depends on the protocol and everything, that you get notified when there's a reply. Okay. So then you can respond to that reply and then follow up with whatever you want to do afterwards, right?
So it's a bit like a message queue then?
Yeah, it's a bit like a message queue. And that's also where the reactive part comes in a little bit. But the point is that even if you're using a message queue, you can still use it in a blocking way.
Yeah.
And if you block it somewhere, then the whole stack is blocking. So if you really want to benefit from non-blocking, you need to do it all the way through.
So what happens to when you get this message coming in saying, I've done your request, I'm ready, you can pick up this information. What happens then to make that non-blocking? So
it kind of depends on how you look at it, at which level. But generally, when you're, for example, talking over a network, you might get a little bit of data, not everything yet. And then you generally want to be able to take that bit of data and then process it somehow, knowing that there will be more, that you don't have to wait until everything is there until you can continue. So generally, you keep on receiving pieces of data and dealing with it, and that's a whole different way of thinking than blocking code. When you do things, now things happen and you deal with it, and that requires quite a bit of a mind shift.
So this is where streams come in.
Exactly. So if you use a normal blocking style procedural code, that's going to go, I mean, it can be done, but it gets very, very complicated very quickly when you just want to respond to events happening, because then you have to have callbacks, and then the callbacks has callbacks, and then you get like a huge mess. And even if it works, nobody ever will dare to touch it, because if you change anything might break. So for that, the reactive model is much more appropriate, because then in the reactive model, you kind of look at the data streams as a stream of things coming in, and you define for everything what to do with it. And you completely lose the concept of threads, actually.
Yeah. And does that help with managing resources like memory as well?
Yes, definitely. So, for example, if I have a big file, like a big XML file or whatever, and I stream it in, and I'm looking for something specific. So I don't need everything, I just need something specific. And I just can watch the stream and throw away what I'm not interested in and just take the parts I need. That's so much more efficient than first reading the whole thing, parsing the whole thing, and then go looking through it, and then finding the thing. Because you could have thrown away a lot earlier. So and then you can get into situations that if it's a really big file, you might simply not have enough memory to read the whole thing.
Yeah.
And even though you only need that memory for a fraction of a second, you still need it. And if you can do it in a streaming fashion, that you're just walking through it and discarding it straight away, you can get away with a lot less memory.
So what type of applications benefit from this way of thinking? Is it more like web-based applications? For example, I mean, the most obvious example I can think of is streaming films or...
Yeah, true. Well, I mean, for films, it's generally, in some way, there is a streaming way to do it streaming, because video is so big that you're generally, if you watch a video on YouTube, you don't get it download of 100 megabytes and then the video starts.
Yeah.
Right? So there are ways to do it at different levels. But it works so much better when you can do the streaming at a lower level. So if you can, even if you like query a database, if you have a reactive driver, you can straight away stream the results in and deal with them as they come in. And you don't have to wait until everything is done.
Thank you very much.
Thank you.